Hi guys, so this is the homework video. Just to review, here's how you're going to use these questions. There's 8 questions. Obviously on a test we would do those 8 questions in 15 minutes. But here's what I suggest for you at home. First, sit down in a quiet space and put away your notes and set a 15-minute timer, pretend like it's the test, and see how that goes. Can you answer them all? Can you answer 5 of them? Because that would be a good grade. Can you answer 3 of them? When the timer goes off, think about the strategy you used. Did you use your time wisely? Did you do the easy questions first? And then take some time to actually finish solving the questions you didn't get to. And if you need to, you can use your notes, right? It's your studying, you know what's productive. It's useful when you're thinking. It's not useful when you're sitting feeling completely stuck. It's also not useful when you're just getting the answer because you're copying it from your notes or you're having it explained to you. So feel that thinking and prioritize your time that way. Once you've answered all the ones that you can, using any strategy you know, input your answers into this video and it'll tell you if you're right or wrong, and then I'm going to ask you to check your answers, as in listen to the explanation that I give for each question. I'm not going to enable skipping. I am going to try and be efficient about how I explain questions, but I'm going to actually ask that you listen to the explanation for all of the questions. For the ones that you got right, that's just like a little pat on the back that you know what you're doing. Okay, let's get started. In case people use this video to review later, I'm going to go ahead and just scroll through each of the questions very briefly. This is 1 and 2. All right, here we go, answers. We start off pretty basic here. When it says f prime of 8, question number 1 is telling me to take the derivative and then plug in 8. To take the derivative, I just used a really simple power law. This is just a normal thing where we take the exponent, multiply it in front, and subtract 1. 4/3 minus 1 is 1/3, and then to multiply the fractions, 4 times 5 is 20, and 3 stays on the bottom. The 1/3 power is the same thing as the cube root, so that when I plug in 8, the cube root of 8 is 2, and I just multiply on the top, which is why the answer is B. Number 2 is also really quick. Basically, when you're taking the limit at infinity, we have this trick, which is to look at the degree. If the degree on the top is larger, we could be going to positive or negative infinity. If the degree on the bottom is larger, it'll be going to 0. In this case, we have the same degree. So I take the coefficients from the highest degree term on the top and the bottom, and that's just the answer to the limit. Make sure that you're careful because that only works for limits going to infinity. Question 3 was a quotient rule. And you can see here that I set up low d high minus high d low. This is a 6. Sorry about that, it looks a little messy. 6x minus 1. From there, my next step was to FOIL out the 4 pieces, and I FOILed the second half and I distributed the negative sign at the same time. So don't forget that those are supposed to be negatives. If you have the wrong signs there, it's because you forgot to flip. And then I combined like terms, which gave me negative 6x squared. And then I actually probably might have been tempted to stop there, but since none of the answer choices have that negative 6x squared, I'm going to keep going. And I was able to rearrange the expression like this. First of all, I recognize there's a GCF on the bottom, which is an x in both of these terms. And the GCF I took out right here in the inside, but it's still being squared, and that's super important that you remember to square both of these pieces. So when I take out the GCF on the very, very inside and then square it, it's really the same thing as x squared times 3x minus 1 squared. Both of them are being squared. Again, if you don't see the connection, pause the video and think about why algebraically this is the same as this. The rest is a piece of cake. The x squareds cancel out, and it's clear that the correct answer should be C. Question 4. This was actually just a pre-calc question. They give you two functions, and then they tell you to compose them, to take the g of x rule and plug it inside of the f rule, and then to plug in 2. Here's the work. And just double check that you remembered to square the coefficient as well. That's because we're squaring the whole thing. 3x times 3x is 9x squared. And then order of operations, make sure you square the 2 before you multiply times 9. And piece of cake. All right, let's keep moving. For question number 5, we're looking for the slope of the line tangent to this graph. I know that finding the slope that's tangent means I'm taking the derivative at a point, and I've got the point right there, that's clear. Now, to take the derivative, I've got an equation where x's and y's are kind of mixed up, so I'm going to have to take the derivative implicitly. Remember that that means taking the derivative of both sides and treating y as if it's like f of x, it's a function. So doing this is pretty straightforward. That's just a regular power rule. This is the good old chain where ln of something is the outside function and the derivative is 1 over that thing. And the inside function is y and its derivative is y prime, and the 5 just hangs out in front. That's a constant multiplier. And the derivative of a number is 0. I paused here because the next step might trip some people up. I want to get y by itself. Normally what that means is dividing both sides by its coefficient, which is 5 over y. So if I do that, I would get y prime equals negative 6x divided by 5 over y. Well, that's really an ugly way to write something. So instead of writing it that way, it's preferable to do kind of fraction rules here. Negative 6x times y over 5. In other words, negative 6xy over 5. And that's your derivative. Well, that's the derivative function, remember? But we're looking for the derivative at a point. So then my last step is to go ahead and plug in x and y. That's easy enough. Plug them in, x and y right here, and we get negative 12 over 5. If you need to look at any of this work, go ahead and pause. Otherwise, I'll move on. Negative 12 over 5 was a, which is why a was the answer. Okay, so number 6 was ugly. I apologize, sort of. It's good practice. The good news is at the end you get to plug in 0, which is easy. But first we have to take the derivative. What I see primarily here is something times something else. So, yep, product rule. As usual, I'm going to go through and fill in the easy parts first. We've got u times the derivative of v and v, and then it's the derivative of this square root expression that's kind of the complicated thing. Everything else is straightforward, and it's worth writing it all out first so that you don't forget it's there. Now, how do we take the derivative of this? Well, it's the square root of something. That's right, it's a chain rule. Now, the outside function is the square root, and the inside function is the polynomial. It's very easy to take the derivative of this one. It's just going to be 3x squared plus 5. But the derivative of the square root requires that you remember a square root is the same thing as the 1/2 power, which means that this is the same thing as saying something to the 1/2 power. And how do you take the derivative of that? Well, that's just a power law. Multiply the 1/2 and then subtract 1. So it's the something to the negative 1/2. And this is the same thing as 1 over 2 times the square root of that thing. Again, I'm just rewriting the negative, puts it on the bottom, and the 1/2 makes it a radical. To put the chain rule together, I start with this, I plug in this, and I multiply this. And remember, the chain rule is just your last piece here. Don't forget the other 3 parts. We'll put it all together. And there we go. Now, there's good news. This is the derivative. And it's a horrible, nasty looking mess, which you could simplify. But the really good news is that we don't care about whether or not it's simplified. We care about what it equals when we plug in 0. And 0 is this wonderful, simple number that is so easy to plug in. I'm not even going to bother simplifying this. I'm just going to plug in 0 because that's really easy to do. And I'm going to make sure that I preserve the order of operations. But if I look inside parentheses right here and plug in 0, that turns into 0 and that turns into 0. And we just have the square root of 121, which is 11. And if I plug in 0 right here, this goes away and we just have times 1 plus, and you're getting the gist of this. When I plug in 0 to this term, it just is 11. And then in parentheses, we're going to be really careful here. When I plug in 0, this goes away, and this is 121. So the square root of 121 is 11. And I multiply it times 2, and I keep it on the bottom of a fraction. That becomes 1 over 22 times, this all goes away except for the 5. And that's it. So we simplify from there. And there's a lot of ways you could do this little algebra, but basically it all comes out to be 27 over 2. If you need more time to look at the last couple steps, go for it. Otherwise, 27 over 2 was the answer. B. Let's talk about 7. So number 7 was just a chain rule. Hopefully most people got this far, where the outside function is 5 to the something, you know the rule for that derivative, and the inside function is very simple. Now, what's hard is that you may have gotten stuck at this stage, or maybe you rewrote it to put the coefficient in front, but either way, this is not an answer choice. So what do I expect from you in this situation? Well, if I were you, I would start by eliminating some things that you know are wrong. And this is really about trusting that you are doing this right and you know what you need to do and you're very smart, and you can probably even answer it without knowing mathematically what the answer is, just by ruling out wrong choices. For example, this is clearly wrong. Like, this is missing the ln altogether. It's got the 3, but not this thing in the front. There's no way that's the right answer. Similarly, when you look down at this answer choice, this is like a red herring. This is a wrong answer choice in case somebody tried to use the power rule, where you subtract 1 from the exponent and multiply the exponent in front. That's not what we're supposed to do in this situation, so that's also clearly wrong. And B is clearly wrong because it's got the 3 ln of 5 on the bottom for some reason, who knows why. From there, you get to make a judgment call. I think the 2x is pretty obviously wrong as well. And so maybe, if you're with me, you think the answer is A. A is the answer, and if you really want to know why, I can show you very easily, but you need to remember an algebra 2 trick. When you have a number times a logarithm, you're allowed to take that coefficient and make it an exponent. So this is the same thing as the natural log of 5 cubed, and then again times 5 to the 3x. Well, 5 cubed is 125, which is where ln of 125 comes from, and indeed proves that A is the answer. Question 8 is limits. Hooray, limits. Obviously, the first thing you should always try in limits is to plug in 0. But if I do that, I get 0 on the bottom, so I know I'm not allowed to do that. Now, if there's a way to rearrange this, I may end up with a limit that actually is a number. Sometimes, however, you can't simplify or get rid of the 0 on the bottom, and that's when it would be undefined. And it's kind of a gray area as to which one it's going to be. It's really about, can you think of something to try? One of the things that I can think of to try is that I know there's a rule about sine and x on the bottom. So I'm going to try rearranging this limit. Here's what I came up with. I pulled out sine as a GCF. And I'm actually noticing that the next thing I want to do is to even split it one more time into 2 fractions, where I have sine x over x, because I know that I can take the limit of this expression and that it equals 1 when x is approaching 0. Now, I'm not allowed to split up this limit and evaluate like the limit of 4 and the limit of sine x over x until I know for sure that this last piece is defined, right? You can't split the limits up and evaluate them unless each piece has a real answer. As of right now, the last one doesn't. If I plug in 0, I get 0 on the bottom. That's no good. So the solution is to try a conjugate. And so here's what the rest of the work looks like. This conjugate turns into cosine squared minus 1, which trig identity is the same thing as sine squared. And then I can cancel the sine squared and the x squared out using that same identity. And 1 over cosine. You can just